Half a day students, today we're going to be going over more applications of the power rule. So we're working with derivatives. We're going to firstly look at different notations of derivative and then some of the properties, and finally dealing with exponential notation changes. So let's start with notation. Derivative notation given y equals f of x. So we have two different ways to represent this. We have dy dx and f prime of x. Again, these two different ones, they're both the same thing. It just happens that one is Newton's notation and one was Leibniz notation. And like I said last class, they were actually developing calculus at the same time. So that's why we have two different notations for it. You might also see something like this where we have derivative with respect to x of something. So f of x or polynomial in there, some kind of function. You might also see a derivative written this way where you see dy dx where x is equal to a certain number. Okay, I'll just put a number sign there. Usually we'll use c for constants, but just say okay. So this is the same as f prime of a number, right? F prime of c. So basically all it means is just to plug in the number once you find f prime. So once you find the derivative, plug whatever that number is there into it and then evaluate. So now we're going to look at some derivative properties. So these are actually ones that we went over last class. This is just us writing them out, right? So this first one tells me that the derivative of the sum of two functions is the same as deriving each of them separately and then putting them together at the end. So this we actually did last class. Okay, so maybe if I say, let me change this color, d dx of 3x to the third power plus 2x. Okay, the derivative of that, we have two different functions, right? We can say, okay, a polynomial is made up of different terms, so you have two different ones. This is the same as splitting it up. It's called the summation property. So basically, the sum or difference, you can split it up and put it together when it comes to derivatives. So this is going to be the derivative of 3x cubed plus the derivative of 2x. And I know the derivative of 3x cubed is going to be 9x squared. Derivative of 2x is just 2. So that's an example. Looking at this next one, y is equal to a times x raised to n. The derivative of this is going to be a times n times x raised to n minus 1. We did it before. This is just the formula, the correct notation for what we did when we used the power rule. So what this is saying is we're going to take the exponent, multiply it to the coefficient, and then reduce our exponent by 1. So showing the example, if I was to have finding the derivative of 5x to the 10th power. This, I'll take my exponent, multiply it to my coefficient. So we have 5 times 10. Then we have x raised to my exponent reduced by 1. So 1 lower. 50 x raised to 9. This third one is actually telling me that when I have a times x raised to the first power, so any number times x, its derivative is just going to be the coefficient. So if I wanted to find the derivative of 4x, I already know because of the power rule, this is just 4x to the 1, right? So I'm going to multiply by 1 and then subtract 1 from my exponent, which comes out to 4 times x raised to 0. X raised to 0 I know is just 1. So it comes out to 4. So I can just assume, okay, 3x. The derivative of 3x is just 3. Okay, so if you're looking at this last one, where our function is equal to a constant, just a regular number, our derivative is going to be 0. And this is because, for example, if this is finding the derivative of 5, right? 5 is the same as x raised to 0, right? So we have d over dx 5x raised to 0. So this comes out to 0 times 5, or 5 times 0, sorry. Doesn't matter. 5 times 0x raised to 0 minus 1. But it doesn't really matter because 5 times 0 just comes out to 0, right? So we have 0. So the derivative of any number with no variable is just 0. Some review on the power rule. Okay, so evaluate f prime of -1 for f of x equal to 11x to the 5th power. First thing I'm going to do is find what f prime of x is. So I want to find f prime of x. That's going to be 11 times 5, or multiplying by our exponent, reducing our exponent by 1. So we have 55 x raised to 4. And you actually don't even need this first step. Just jump straight to 55x to the 4th if you want. That's completely fine with me because that's easy math, right? For now, I'm actually going to plug it in. F prime of -1, plug that in for x. 55 times -1 raised to 4. I'm going to use PEMDAS, so I'm going to evaluate my exponent first. I know -1 raised to an even power is going to be +1, right? Because negative raised to even is positive, negative raised to odd is negative. So this is going to be 55 times +1, which is just 55. Another example, same thing. Now I'm going to just find f prime first. 7x to the 4th power, multiply by 4, right? And then reduce this by 1. This is going to come out to 28x cubed. Again, you can jump straight to that if you want. Now we're going to plug it in, f prime of 1 over 5. I do want to see you find f prime of x first and then plug it in. Okay, then we have 28, 1 over 5 cubed, 1 over 5 cubed. You can distribute that exponent since you only have one term in the inside. 1 cubed over 5 cubed. 5 cubed I know is 25. So we have 28 times 1 over, not 25, it's 125. Okay, so we have 28 over 125. If you're unsure, you can actually just use your calculator to check if it's simplified. But again, for calculus and the AP test, they will accept unsimplified ones. But for the most part, something like this would actually be a multiple choice, so you'll have to know what the simplified version is. Okay, now we're actually going to move into a problem where we're going to change the notation of our original function y without changing its value. So we'll show an example here. We have y is equal to 9 times the cube root of x squared. So what I want to do is I want to force it to be something like this, right? Where we have a x raised to n. Because if it's in that form, then this is something I can derive really easily using the power rule. So we want to force it from 9 times cube root of x squared to a number in front times x raised to an exponent. And this is something that we went over on the first week of classes when we wanted to look at different strategies in algebra that we're going to need for calculus. So first thing I'm going to do is find the equivalent of this function. So we have 9 times the cube root of x squared. This I know, when I have cube root, that just means raised to 1 over 3, right? So I know this is 9 times x squared raised to 1 over 3. It's getting a lot closer. Now what I'm going to do is combine these exponents. So we have 9 times x raised to 2 over 3. When you have an exponent raised to an exponent, you can multiply them together to reduce to one exponent. So we have this, 9x raised to 2 over 3. This is now in this form, right? So I can now use my power rule. So I'm going to just say, okay, now I want to find the derivative. Change color. Derivative of, 9x raised to, Okay, and this is come out to, I'm going to multiply 2 over 3 to the beginning, so 9 times 2 over 3, x raised to 2 over 3 minus 1. We're using the same formula we did earlier. 9 times 2 over 3, I know it's going to become 6, so 2/3 of 9 is 6. X raised to 2 over 3 minus 1 minus 3 over 3, right? So we have negative 1 over 3. Negative 1 over 3. So you can have it like this. If it's a multiple choice, they might give you another equivalent of this also. So negative 1/3 is, I know, going to be a cube root, but in the denominator. So this would actually be equal to 6 over the cube root of x. So both of these are possible answers. Like I said, you have to be prepared to know that they're both the same if it's in a multiple choice question. So just to recap, first step, change your original function into exponential notation. Second step, derive. Third step, change it back to regular notation where you have square roots, if necessary. Okay, now we're going to look at the power rule. We're again changing to exponential notation. This one's actually a little bit easier. What we're going to do is simplify each of them and put them all into where it's a number times x raised to n for each of them, right? So let's look at y. 3x to the 6 over 6 plus 2 over 3x minus 9. This I'll simplify. 3 over 6 is 1/2. X raised to 6, that's in the numerator, so I don't need to touch it. Plus 2 over 3. X is now x to the 1 in the denominator, right? So that's equivalent to x raised to -1 in our numerator. If you're unsure about properties of exponents, this is something that you do want to get very comfortable with. I have a video on my YouTube for it if you want. Otherwise, there's a lot of videos on YouTube. And then minus 9. Okay, deriving this, I have 1/2 x 1/2 times 6 x raised to 5, right? Plus 2 over 3 times -1 x raised to -1 minus 1 becomes -2. And then derivative of just a number is going to be nothing, right? Simplifying this, we have 1/2 times 6, we have 3x raised to 5. This becomes minus 2 over 3. Then we have x raised to -2. We can also write an equivalent equation, which is 3x to the 5th power minus 2 over 3 x squared. Okay, moving on to the last problem. Okay, so now our last problem, what we're going to do is we have a rational expression, right? So what I'm going to do is split it up into 4 different terms and then simplifying and then finding the derivative. Okay, so we have f of x is equal to 3x to the 5th over x plus 2x raised to 4 over x minus 3x over x plus 5 over x. From here, I'll simplify. X to the 5th over x is x to the 4th plus 2x cubed minus 3 plus 5 over x. But we actually might want to put this into the notation form, right? Again, we always want it to be a times x raised to n. So to put this so it's nicer, I'll make it as raised to -1. Okay, now I'll find the derivative. Let's change colors here. F prime of x is 12x cubed. I'm just jumping straight to the derivative now because it's a little bit easier for us now, right? So we have 2x cubed, I'm gonna multiply by 3. So we have 6. X raised to 3 minus 1, so x squared. Now we have a number, -3. If there's no variable, the derivative is 0, so that's actually going to be nothing. And then 5x to the negative 1, multiplied by negative 1, so we have negative 5x raised to negative 1 minus 1, which is negative 2. I might have to find the equivalent, or maybe, hey, maybe you don't like negative exponents. 12x cubed plus 6x squared minus 5 over x squared. Okay, so that's it for today's lesson. I hope that it's clicking in your brains. Please do try some examples. We'll likely be having a quiz on this next week. We'll definitely be going over it together beforehand, but enjoy. This is actually like the most fun part of calculus, so I hope you like it, and have a great weekend.